All right, so we're going to do this 2018 number 4. And so, of course, this first one, you could tell that it was an experiment because you randomly assigned to the treatments. Remember that with an observational study, you just observe already existing conditions. Experiment, you randomly assign to the treatment groups. So we are then given information, and we are asked if we have convincing statistical evidence. So that is going to be a hypothesis test. So that is giving me the information that we're going to do phantoms. Okay? So is there statistical evidence that those who receive the new procedure have less recovery time on average than those who receive the standard procedure? All right. So I can tell that first, did we have two separate, even different sample sizes? Oh, yeah. See, so here I even had 110 that were getting the standard and 100 who were getting the new. So I definitely do not have paired data, okay? Because they're not going to do more than one surgery. So it's clearly two separate populations. The population of those who get the new standard procedure, those who get the new. So therefore, we are making an inference about two separate populations. And so I start defining both of those populations that we're going to be making an inference about. And I'm going to make an inference about the average recovery time from the standard procedure for all those kinds of patients and the average recovery time for the new procedure for all those kinds of patients. Now, null hypothesis is, see how I list two separate means here. Are those the same? Or is the standard greater than the new? Now, if you had written this is the new less than the standard, okay? So has it reduced this is fine. Whichever way you do this, it's fine. You just have to be careful and watch how you put your data into the calculator, okay? So let's take a look. Let's move on down and take a look at that. All right, so first of all, then the assumptions. Then again, we did not have random selection. These were volunteers. But it is an experiment. So remember, if we have experiment, then we have to randomly assign to the treatments. So we had 110 patients randomly assigned to the standard and 100 patients randomly assigned to the new. And with that being volunteers, then that's an infinite, or I can't say, what is that, less than 10% of all people who could do this? So that 10% thought process doesn't really make sense in the real world. So that's when we're allowed to leave it off, okay? It matters if we're going to sample without having that replacement. But this is still important. We still must make sure we say that the subjects who got the standard procedure are independent of those who got the new procedure. Okay, remember you have to define that they're two separate. Nobody was counted and double counted in both groups. Okay, and then large enough for means. Remember that your sample size is greater than or equal to 30, and lovely, they both were. So bam, they're large enough. Approximately normal model applies. Don't forget that. Approximately normal model applies. Okay, so I have a 2 sample t-test, or a 2 mean t-test. Okay, so 2 sample t-test for means or 2 mean t-test. You could write that also. So I want you to look at how this went into the calculator. That's important. So let me make sure I got it straight. So the way the data was presented to me, I put standard in first. So if you chose to put standard in first, that's probably the way students do, and that's fine. So let's zoom in on that and look at how that looked on my calculator. And the reason that you have to pay attention to what you're putting in first is so that you can carefully do the inequality sign there. Okay? All right. So I guess so I have the mean and standard deviation of the first set of data, that was the standard. And then I have the mean, standard deviation, and sample size of the new. So I put the standard in first and the new in second. And so they were seeing, is the new reduced? So is the second one lower than the first? So therefore, that's why I did this one. Is the first one greater than the second? Now, had I flip-flopped these numbers and I put new in first and then standard, then I would flip-flop that sign. So pay attention to which one you put in, and so you know the order that it needs to go. So it's pulled, or no, we never pull. Remember, it's cold. Nobody wants to see Miss McClellan in her swimming suit out in the pool. Okay, no go. So we definitely never pull. And so once I do that, I get a t-score of very large, 7.13. Now look at this p-value, 8.36, and you can't have a p-value greater than 1. So if that happens, look at the end. This p-value is 8.36 times 10 to the negative 12th. So it's 8.36 times 10 to the negative 12th. So it's essential, it's so small. That's 0.0000, all the zeros, and then the 12. And so that's essentially 0, okay? And then do just write the degrees of freedom. We do not have to be able to compute that in this course. All right, so now let's go ahead and make our conclusion, our p-value being essentially 0. Then we're going to go ahead and reject the null hypothesis, and we have enough evidence, remember that, we have enough evidence to indicate that the recovery time, so this I can list separate. The average recovery time for patients on the new procedure is less than the average recovery time for those on the standard. So I can even say the word average twice. So I am not loving the way I wrote this summary here. So let's talk about maybe a better way to put that. So I'm going to say there is evidence that there is enough evidence to indicate or suggest that the average recovery time on the standard, or since we're asking about the treatment on the new surgery, with the new surgery is better, the average recovery time, okay, and so on. So you need to word it correctly. So the average recovery time on the new surgery with the new surgery is less than the average recovery time with the standard procedure. Okay? And so on. So there you go. One other thing is make sure somewhere, you included the DF because that was a weird degrees of freedom and that was in your calculator. Okay, that's it for that one. So a couple little things on there. Just make sure you're indicating everything as in 2 separate means, and because we had 2 separate samples and 2 separate populations. Okay, thank you.